Greetings, Internet. My name is Waffle. I work at Discovery Place, and I'm a maker in the thinker space. So what this pretty much means is I spend my days helping kids work on various activities and construct things. And today we're going to be learning about my favorite piece of equipment, 3D printers. And to kind of understand what 3D printers are, we have to think about how you make things to begin with, okay? So, from the safety of my home, we can see that I have a remote. Right, this remote is made up of multiple different pieces. If you look, you can see there's little screws in it. We've got different things, bits and pieces, buttons and whatnot. So this is traditional manufacturing. Make a bunch of different bits and pieces. Now, let's say I wanted to make this statue, right? And I wanted to make it out of one piece. Okay, you see this bird? Looks pretty cool, right? Got it on one of my travels somewhere. This is subtractive manufacturing. So you would start off with a solid big piece of wood. Right, you would get your whittling knife out and you would start working on this. Okay, you might not use a knife, you might use a file and kind of work really hard. And after a while, you can subtract a lot of stuff out of this so that you're just kind of left with the thing you want. Okay, subtractive manufacturing. Now, I have this bird right here that's made out of wood, and I have this owl right here. And I'm going to say that even though they're both birds, they were actually made completely different ways. So this first bird, right, if you actually look at the top, you can kind of sort of see grooves, and it was carved, right? You had an artisan that removed stuff, subtractive manufacturing. But this owl, right, I'm going to see if you can look on the bottom right there. Do you see those lines? Do you see those layers? So this owl was actually made the opposite way. So instead of taking a solid block and then cutting down until you have an owl left, you start with nothing and build up until you have your owl. So this is additive manufacturing. The easiest way to think about this is we're going to take a bunch of pieces of cardboard. Okay, so I can put down one layer, I have one piece of cardboard, put down another layer, put down another layer, and by adding all my layers together, you can make a solid thing. Now, this is just a simple square, right? Nothing fancy going on there. But if I can change the layer sizes, so I could start off with a small circle, maybe put a slightly bigger circle on top of it, put an even bigger circle, then another medium circle, and another small circle. And this makes like a little UFO. Right? So by adding together all these different layers, you end up making one solid object. So this is actually how 3D printers work, except instead of they draw one layer at a time, but they actually do it even slower than that. So we're going to kind of tilt this down to where I am right here. Okay, cool. So the way the 3D printer works is I'm going to make a print, and my name's Waffle. So I'm going to start off with a W. So what I'm going to do is I'm going to trace and kind of draw the outside of the W. This is actually a lot harder to do upside down than you would think. Boom, got the outside of the W. And then I will go in, and one path at a time, I'm going to lay down layers of plastic. And I'm just going to keep filling it in until I have my W. So now I've made a W, it's all solid, and this is how a 3D printer works, but with plastic. And so that is what we're actually going to look at next. Alrighty, y'all. So now we are looking at a Prusa. This is a Prusa i3 Mark III's. And this is the 3D printer. So if you look right here you have the hot end and the extruder. So if we actually pan up a little bit, this here is the plastic, right? It comes in a little spool of thread. It's called filament. And what happens is it will be fed from down here all the way down and kind of go into this hot end where everything gets melted, okay? So if you look at me, you can see this is a 3D model of this hot end. So you can kind of sort of see that it's a little bit bigger than what the thing is. But we're actually going with an adventure. You might be able to see inside there that little circular ring, right? That is this right here. So inside the printer, what we do is we have this little piece of PFPE tubing. This is made of plastic that's resistant to heat, and so keeps the filament kind of goes through here, goes into about this area here, and down here, you actually have a little heater cartridge that goes through here that heats everything up nice and hot. So this little heater block, when we print with ABS, for example, is actually at 250 degrees Celsius. So that's really hot. That's over twice the temperature of boiling water. And all the 3D printers, one thing that they have in them that's very interesting is a heat break. So if we kind of look, you see that tiny little gap that connects this hot end to this cooling end? So because this is very hot, you don't want to heat up the whole machine, because then if you touch the machine and you put your hand on the frame somewhere, you get burned. So by having this tiny little gap of metal there, the heat doesn't transfer through there very quickly. And so you can have this to cool it off, and that's actually what these fans are for. So there's a little fan here that's actually blowing air across this all the time, so that you can cool this section here and still have this end nice and hot. Right? So that's this little hot end right here. It's actually down here. Here you have a motor that kind of feeds the filament. So what I can actually do is I can go down here and change the settings. Settings, move axis, extruder. So as I go, we're actually going to see start feeding plastic through. There we go. You kind of sort of see. It's spitting out plastic. And so it's not a lot. It's actually pretty thin. Right? But you can actually see it's just kind of spitting out plastic, one little piece at a time. Okay. Ooh, refocus. There we go. Now, when we draw things, when we create things, right, you saw my hand using that marker, that W wasn't very good, right? It was wobbly, not perfect on either side. So what this does is the machine helps make everything very precise. And so we actually have 3 axes. So you can see the printer can move back and down like this. This bed can actually move back and forwards. And then, if I actually use the control, you can see that I can make the Z-axis move up and down. So the way the printer works is you combine your X, Y, and Z motion to build things. And so if you look at something like this little dragon, what you'll see is we got a bunch of nice shiny layers on the bottom, and you see that it traces an outline, and then kind of colors it in. Moves up a layer to do it again. You can definitely kind of sort of see the layers on the wings. Okay, so what I figured to do would be fun would be watch to print something, right? So, in honor of Waffle, that's me, we're going to print a W. So we're here, we're going to see how it goes. Alright, so what it does to start is it hones. So you see it's going to bump into the bottom there, it's actually going to move the bed back and hit, and then there's actually a little probe. You see that little white thing right there that kind of sticks out with that cap? We're actually going to look at that red nut on top. So what it's doing right now, is it's actually measuring where the bed is. So if you imagine we have eyes, we can see where we're drawing and how we do things. A 3D printer draws with its eyes closed, basically, because it doesn't see anything. So it will say, hey, I want to draw something. I'm going to move 1 step forward, 2 steps forward, 1 step left. And I drew like an L. And then I'm going to go back home, and I'm going to go 1 step forward, 2 step forward, 1 step left, 2 step left. And so it kind of just uses that as a reference frame. So what this is doing now is I'll actually move it up closer so you can see. Really enjoy. Make sure it's stable. There you go. So you can see right here, it kind of draws a little purge line just to make sure the extruder's ready. And then it starts drawing the rest of the stuff. So in this case, it's actually going to be a W for Waffle. And this print is going to take about 6 minutes. And so while this is kind of slowly making its way, actually might be able to take it down so you can kind of sort of see. Let's see. So there's something down there. Yeah. It is slowly building stuff. Cool. Alright. So we're going to go back. Keep looking there. Alright, we're going to keep watching that being printed. So it's going to, you can actually kind of sort of see. Alright. So, what things can we 3D print? Alright, so we're watching this thing print. It's going to print for about 6 minutes. But what's the point? What's the use? Well, you can make some really complicated stuff with 3D printing that might be very hard to make otherwise. So, for example, in here I have this little cat. So if you look at this cat, we see it's actually all made with all these holes in it. The effect is called Bernoulli, actually. You make things low poly and then only show where their edges are. But making something like this would be very difficult, right? Because this cat is not only completely hollow, but most of it's hollow too. So you could get someone to sculpt a cat out of wood, and maybe you could drill some holes in it to kind of get this similar effect, but how on earth are you going to make this thing hollow on the inside? It's just a little bit too complex to do reasonably. Right? If you want some teaching aids, if you want some high-tech parts, this is a 3D printed jet engine. So this is a model of how one works. You can actually see all the different little bits as they move. And so there's, right now in industry, they're actually 3D printing aircraft and rocket engine parts. So if it used to be very hard and very expensive to take a solid block of aluminum and try to cut all the grooves and all the things out of it, if you could 3D print with metal and actually build up the layers on top of itself, you could make something faster and stronger, which is pretty cool. 3D printing allows you to make things that have moving parts. So when we looked at this, right, each of these were separate parts. So I made this and you can even see that the fact that this thing wiggles separately from everything else, I might be able to, there we go, might be able to actually pull this off. Some 3D printed things you can actually print interlocking. So this is a little slide puzzle. Kind of moves around, lots of fun. This printed at one time. So by printing these little squares with enough of a gap in between them, you actually have it come off the printer looking like this, and you didn't have to put anything together. So people ask if they can take it apart. I say you can take it apart only once, and then it's broken. Likewise, if you thought that was cool, I have a little container here. Right, we see a little container, we kind of see the bottom, we see there's some grooves going on, right, which immediately might tell us that something is pretty weird about this. So you guys might have seen this type of action before, right? Irises and cameras. So this actually comes printed like this. It prints in the open stage, and you can if you look down it, you can see the little things. And if you actually pivot them open and bring it close, you should be able to see the layer lines, right? Especially coming down the side of it. And so this, print things, interlocking, that don't come apart. All right, if you want a little octopus, shake this thing off. A little octopus, right? Prints a little chain. This link, once again, interlocking, can't take it apart. So, how could this be important? What could you do to make these things? Well, imagine if you needed to make someone a prosthetic limb or something, and you wanted to make sure that it fits where their arm is, and have it just custom fit for them. Well, you can take a scanner, you can scan that person's arm, and create a model of exactly what it looks like. And when you're done, you can just 3D print that exact same shape. If you want to have a complicated set of pliers or grab tools, instead of making multiple pieces that you then have to assemble together and use screws and stuff, if you can make it that it prints in one solid piece, well, Now it's one solid piece. A lot of the reason things break is because where two pieces come together is the weakest part. So if we're able to start making things out of one solid piece, it would be a lot stronger. So you could imagine that to make a car frame stronger, instead of coming up with a bunch of different components that get bolted and welded together, it would be a lot easier if you could just 3D print the frame. Now, as we say this, ta-da! We got my W, my waffle. All right, so I'm going to take this off the bed. Ooh, this is very hot. You can see the W. Ooh. Gotta flex to get this off. Come back. Whoops. Did not let that cool enough. Ta-da! And there, I'll actually hold it up here to see. Ta-da! We got it. So ordinarily you would let the print cool for a little bit, so that way it stays nice and hard. I was a little excited for the video. But we can actually see here, right? We can see the W. And then, I guess I can actually make this big again. Whoa! So here if we look, actually might be able to see. Come on, buddy. Show us the lines. There are layer lines there. You'll just have to believe me. W. So, yeah. My name is Waffle, and this is a brief introduction to how 3D printers work. Join me next time. We'll be able to learn how you actually program and talk to the 3D printers. So, stay safe, y'all.